Hi everyone. We're going to start talking about transformations. Um, we just talked about absolute value and how to graph that using the tables. So I want to start talking about how to do it just from little shortcuts, little transformation shortcuts. So your general form for transformations with any function looks like this. We talked about this before, but it was kind of difficult because we weren't really sure what to do with some things. So your general form looks like this. Okay, this is very general and it will change with each function you use. Okay, so like for our quadratic functions that we just did, what this looks like in a quadratic is we have the parentheses squared, but nothing else changes. Okay, so with a cubic, same idea. You're going to have your x minus h inside, but it's going to be cubed. All right, and as you can probably guess with the pattern, it's going to be the same idea with absolute value. And then if I scroll over here to square root, which we're going to talk about square root after we do transformations, it's the same idea. Okay, so if you remember from quadratics, this h and k that was your vertex. Okay, and that had a special quality with the quadratics. But here, just generally, your h is your movement left and right in your quadratic or in your coordinate plane, and k is your movement up and down. Okay, so the only one that is really special is this h. Remember, a negative h really means you have a positive number. And that's something we talked about with quadratics, which means you're moving to the right. If it's a plus h, that's really a negative number, and that means you're moving left. So we're going to practice this idea. We sort of talked about it in quadratics, but we didn't really do a bunch with it. Just to be thorough, if you have a negative k, you're going down. If you have a positive k, you're going up. And so those are the two main things we're going to talk about in this particular lesson. You've got left, right, and up and down. So we're going to do translations with that. In another note section, we'll talk about A, and we'll talk about reflections and things like that. So using this information, we're going to transform the following. So we need to compare the graph of the function of y plus the absolute value of x plus 3 and y equals the absolute value of x minus 2 to the parent function. This was the parent function we discussed in our last note section. So I'm going to go ahead on these two graphs. I'm going to graph my parent function. All right, so this is my parent function. If you remember, for absolute value, it's this V shape where all your points go up by 1 unit. So this is your parent function for these particular graphs. Okay, so make sure you label so you know what you're looking at. So I'm going to do your y equals x plus 3, the absolute value of that on this graph. So when you're talking about transformations, you don't need to do a table. You can just look at your function and it should tell you where you're going to go. So here, with the form that we just talked about, we have the absolute value of x plus h here. And remember, a plus h means we're going to go left, and we're going to go left 3 units. So all of my points in this particular graph are going to go left 3 units. So if we take all of our points, we can shift them over 3 units. If I just take the vertex, 1, 2, 3, I can then just make that V shape again. And this is our new function. Okay, and if we graphed it in our calculator, it would show the same thing. And I'll pull up the calculator so I can show you as well. So I'm going to take my second graph and I'm going to do the y absolute value of x minus 2. So it is a minus h. So really what we have here is y equals x minus h. And if you remember, a minus h means we are going to go right 2 units. It's always the opposite of what's in there. So I'm going to take my vertex and I'm going to count over 2 spaces, and then all of the other points will follow because they all shift with the graph. So this is our new graph from our parent function. Okay, so it's slid over 2. All right, so I want to show you what this looks like in the calculator real quick. So if you have your calculator, go in to your y equals. Okay, so you can find absolute value in a few places. The easiest place is second 0, because you have absolute value in the catalog. You would just hit enter at ABS, and then you could do x plus 3. And I'm going to show you, I'm going to put the parent function in here as well. And then on your graph, so our parent function's in red, and then our other function, what moved, is in blue. So it looks just like our picture. So if I do the same thing for the minus 2, it should be shifted over to the right too. So if you're not sure, you can always put it in your calculator. All right, so the next one we're going to do, we're going to compare the graph of y equals absolute value of x, and then the plus 2's on the outside. And then same thing, we have absolute value of x minus 4 with the parent function. So I'm going to go ahead and do my parent function real quick. All right, so these are my parent functions. Again, we're using absolute value, but these transformations are true of all functions. So you can follow these rules for any function that we're going to talk about. So it's not just absolute value, it is all of them. So I'm going to do the y equals absolute value of x plus 2. So this one looks like we just have a k, we don't have an h. So we're going to take this graph and we're going to shift up 2 units. So up 2 units. We're going to take our vertex and go up, which means all of these points also follow. Okay, so my new function is going to be here in purple. Okay, and this again is true of all functions. Okay, these are the standard steps for them. So I'm going to do the second one, the y equals absolute value of x minus 4. Okay, so this, I don't have an h, I just have a minus k, which means I'm going to move down 4 units. So I'm going to take my vertex and I'm going to move it down 4 units. All right, so we're moving it left and right and up and down based off what is given to us in the equation. And again, these are standard for all functions. All right, so that's what that looks like. So if we had a quadratic, we could do the same thing. If we had square root, we could do the same thing, but we're just doing absolute value because we just talked about it. Okay, so we're going to take a look at some of this practice. So writing an equation from your parent function given the graph. That's really what we're doing. So we have a parent function, we know its absolute value because it tells us, and we have a graph that's been moved. Okay, so our parent function is normally here, and it moved to the red graph. Okay, so this graph moved down 3 units. It didn't shift left or right, it went straight down because the vertex is down here. So if we were going to write the equation for it, we could say that it's the absolute value of x minus 3 on the outside because it moved down. That's our k value. Okay, so that's what we could do for that one. So if we try another one, okay, we try a different one. We're just going to go ahead and graph the ones that were given, a combination of the two. So we have this general form. I'm just going to write it. And again, we'll talk about A in a different lesson. So for G, we have the absolute value of x minus 6. The whole thing is being subtracted by 2. Our parent function is here. So now we're going to take what they're asking and we're going to transform our parent function. Okay, so this minus 6 means we're going to go right 6. And then after we move right 6, we're going to go, I'm going to do that in orange, we're going to go down 2. Okay, so for right 6, I'm going to take all these points and I'm going to move them right 6. So 1, 2, 3, 4, 5, 6. And they all move with the vertex. And so I'm going to do dotted because this isn't my final transformation. So when you do transformations, I find it's easier to do different colors and do dotted lines. And then once you get to your final one, you can show that it's your final. So the last thing we need to do is we need to shift our green graph, the one shifted right 6, we're going to move that down 2. So we're going to take our vertex and we're going to move it down, which means all these points also move down. Okay, they also move down. And this is my final graph. So if you don't use different colors, you need to indicate in some way that that's your final graph, whether you're using dotted or solid lines. It is very helpful if you would show something. So you would do the H first, and then you would do your K. All right, so I'm going to have you do an example on your own. Okay, I want to take a look at this example. Given the graph of f of x and g of x is x minus equals the x minus 5, and state the transformation that occurs. So we have this function, and you're going to see language like this. It's not the best, but you may see it. It just means that you are taking this function and you're creating, this is the new one, the new from the transformations, and this is the transformation that's happening. Okay, so this function right here, we haven't talked much about. This is a cubic. Okay, so in that cubic function, it's you're putting in a minus 5, which is just the x minus h. So you're going to move this function right 5 units. Okay, and the only real points you have these 3, and I believe we talked about those with the parent functions. So we're going to take the function they give us and we're going to move everything to the right 5. So go from 0, 0, 1, 2, 3, 4, 5. We can't put this 1, 1 on there, but we can put the negative 1, negative 1. And our graph would move something like that. Okay, so this is just notation. So anytime you see that, just make sure that you understand that it's giving you a transformation, and you just need to plug it into your transformation formula, depending on the function, putting it in the right function. Okay, so now I wanted to bring back our quadratics real quick. So we have a word problem here. So the equation that we're given is y equals x plus 3, the whole thing squared, and then minus 2. And it moves from the parent function right 3 units and down 2 units. Is this true or false? So based off what we know, does this equation move right 3, which is h, and move down 2, which is k? And you need to decide if it's true or false. So with our standard, so this would be with a quadratic plus k. If we did right 3, that means we'd have a minus h here, okay? Which means we should have x minus 3 squared minus 2 going down 2 units. And that's not what they gave us, so that is false. So if we were to create our own equation, like this one's asking for, we're going to take our parent function and move it down 7 units. We would have y equals x squared minus 7, because this is k. All right, if you have any questions, please come to office hours. Make sure you do the practice that goes along with this section.